Hello, and welcome in this new video tutorial. Today, we will generate a few Simulink components in RTMaps. If you require a real-time, high-throughput data handling from multiple sensor streams, the RTMaps middleware is the perfect development environment to handle your most complex and advanced systems, especially where data processing, synchronization, and data fusion are critical. Although RTMaps and Simulink are similar in many ways, especially in the component-based graphical interface, their software architecture and temporal execution model are different. RTMaps and Matlab Simulink are pretty complementary software. RTMaps can be used for the perception and decision-making algorithms of your systems, while Simulink is nice as well to develop different kind of algorithms for the control command and signal processing of your applications. If you need more details, please check the link of the article in the video description. The Simulink TLC enables the customization of code generation out of a Simulink model. Through customization, you can adjust the way the platform-specific code is generated. Generating RTMaps components from Simulink models allows you to easily integrate algorithms created with Simulink into a real-time modular environment adapted to the needs of robotics, automotive, and multisensor data processing. Before starting, be sure to have all following tools for the tutorial. RTMaps supports this starting from version 4.7.0, but make sure to get the latest version for all the features. You can check the version of the package installed and check for updates. For our tutorial, we are using the MathWorks package version 3.21.1. First, set up your C and C++ compiler in Matlab. A C++11 compiler is required. Depending on your operating system, Microsoft Visual C++ 2015 or superior, or GCC 5 or superior. Then, install the RTMaps TLC target that can be found in the Tools folder of RTMaps. Please restart MATLAB to apply changes. Make sure you have write access to the RTMaps TLC samples folder. You can launch the test script to make sure everything is set up properly. The test script creates one in port, one gain block with a factor of 2, and one out port. Here's what it looks like when integrated into RTMaps. The input is set using the potentiometer component, with the output displayed on the data viewer. The Simulink model parameters are exposed as component properties, in this case the gain value. Here's a simple Simulink model, the conversion sample. It contains a sinus block, a sum, a gain, and a sine, with 2 inports and 2 outports. Let's see how to generate an RTMaps component. Open Simulink Coder and make sure the RTMaps TLC is selected. You can review the code generation settings. Build the model. Your RTMaps package is now ready. Let's see how it looks in RTMaps. The generated component can run periodically, with the time step set in Simulink or triggered at each data sample on its first input. The exposed model parameters can be tweaked at runtime. The input value can be forced. It has to be set at design time. Now, let's see how to handle arrays of data. Here, we have an array of doubles, processed by a gain. The RTMaps vector size value, which is variable at runtime, can be used by adding the underscore size suffix to the import or output name. The RTMaps buffer size, which is constant, corresponds to the port dimension size of the imports and outputs. In this case, 10. Here's another method for converting a Simulink model into an RTMaps package. You can use the RTMaps underscore model 2pck Matlab function with the model handle as parameter. Here's the RTMaps diagram. The input size should match the port dimension set in Simulink. Here, the vector size is variable. You can see that the output vector size matches the input vector size as specified in the model. It is also possible to access the timestamps of the input and outputs. It follows the same principle as with the vector size, but with the underscore ts suffix. In RTMaps, this example adds a value, set in a property, to the timestamp value of the sample. When using images, you will need 3 separate signals per image in Simulink, each with a suffix. Underscore IPL image, containing the actual image data. Underscore IPL image size, containing the height and width. Underscore IPL image channel seek, a string describing the channels, gray or RGB, for example. For some block sets, including this image processing block, the generated code will use shared libraries provided by Matlab. Make sure the path to the libraries is included into your path environment variable. Here's what the generated image processing component looks like in RTMaps. It converts the RGB video into a grayscale one. If your model uses bus objects for some of its imports and/or outputs, make sure to load the object description. The generated RTMaps component will use the corresponding custom C structs for its inputs and/or outputs. The generated RTMaps package includes a merger and a splitter component to construct the custom struct easily. You can see an example of a single structure instance and a randomly generated array of structures. It is also possible to generate an RTMaps package from a Matlab function, whether from a .m file, a .p file, or a built-in function. And here's what it looks like in RTMaps. This sums up what there is to know about RTMaps packages generation from Simulink. Please refer to the documentation included with our TLC target for more information. Thanks for watching and see you in the next video.